Hello, Algebra 2A. Here we are with 7.6, common log and change of base. Okay, the calculator button, I think it's kind of, well, it's not front and center, but it's pretty obvious where it is. Capital LOG, log, is called the common log. We briefly talked about this last week, that if it's a log with no number under it, okay, it's going to be log base 10. That's going to be called the common log. And that is the main one here on our calculator, right by the number 7 on these TI 84s. Okay, LOG, that's going to be our common log. And then the next lesson we're going to learn about the LN. Okay, so we're just going to practice right away here, typing these into the calculator. What's log of 5? Alright, 0.698970. If we round, I think the homework's going to ask you to round to 4 decimals. So if I actually round to 4 decimals, that's going to bump that 9 up, which is going to make the 9 a 0 and the 8 a 9, so 6990. Okay, and let's try that next one, log 10. Log 10 is 1. Okay, think about that. The common log is log base 10. The answer to this, 1, is the power of 10. That would give me 10. That's kind of a cool one. Okay, so if you're dealing common log and you're dealing with fact or multiples of 10, you should have some really nice answers. All right, let's push pause and have you try those next two over there. Okay, so if we type in log of 18, 1.25527, so if I round to 4 spots, the 7 is going to bump up the 4th spot, that 2 up to a 3, so 1.2553. And can you guess what log of 100 is? 2. 2, yep. 2 is the power of 10. Remember, common log is log base 10. That would give me 100. How can this be used? Or how will we be using this? All right, big stars here. This is a big one. Change of base formula. Okay, kind of how we looked at before, that if you don't have one of the newer or more updated calculators that has that spot where you can put the different bases in, before it would make it very difficult. It would make it very difficult to calculate that. You'd have to use this change of base formula. Okay, so if I have log base A of n and I want to change it to some other base, B, we're going to go log base B of what the big number was on top over log base B, our new base B, of A on the bottom. All right, and what we're usually going to do is use the common log, all right, because that's the button that's on our calculator. So we would go log base A of n would split up into common log of n divided by common log of A, what our old base was. Okay, so a little easier to see with numbers. Okay, log base 3 of 7. All right, we could do that with our calculator if you have one of these newer ones with the glowing screens. Okay, log base 3 of 7. All right, but I had to scroll through a bunch of stuff and type it in. Okay, it's just way easier if I can just push the stuff that's on the front of my calculator and I don't have to change things around. Okay, log of 7 over log of 3. The big number goes on top. The little number that's already kind of subscript, it's already written a little bit lower, that's a hint that it goes on the bottom. Log 7, close your parentheses, otherwise you're not going to get the right answer, divided by log 3. These parentheses are very important, guys. Ta-da, same answer, 1.7712. Okay? I think you should be able to handle the rest of these. Okay? Now for a quiz or a test, if we're showing work, especially on your homework, guys, you're going to have to give me the step. If you just gave me this answer, you're not showing that you've learned anything, or you're not you're not showing that you've practiced the formula. Okay, number one, the answer is probably in the back of the book, or Photomath, or Slate, or whatever you're using. Okay, number two, practicing this is what is the most important, and that's what you're going to need in future math classes. All right, so go ahead, quick, and hammer those next three out. Okay, so you need to show log of 23 over log 4. Make sure you're closing those parentheses or you're going to get wrong answers. 2.2618 after you round. Log of 13 over log 9. $1.1674. Important that we work on our rounding skills, guys. 1.16735. All right, I'm not just cutting it off after 4 numbers. If we're rounding to 4 numbers, the 5th number is the one that we're looking at. Is the 5th number a 5 or bigger? Yes, it is. So round the 4th number up 1. If that would have been a 0, 1, 2, 3, 4, we would round down, which in this case would just knock it off. It would be 1.1673. But you're going to need to know how to round. That's an elementary math skill. And I would bet money on a quiz or a test that if they're going to be multiple choice, there's going to be both of them on there. Okay? And if you pick the wrong one, it's going to be -1. They're all going to be worth the same amount of points. So you got to know how to round. Pay attention. Maybe watch a Khan Academy video on 3rd grade math. All right, our last one here, log 5 divided by log 2. We should be coming up with 2.3219. All right, those are the easy ones. Okay, you're just typing them in. All right, let's get into a little bit of solving here. Okay. 2 different ways to kind of think about it. I'm going to show you both. Feel free to pick which one you want. I'm going to show you both up front here on the first one. And then going forward, I'm just going to use the one that I would normally use. Okay. So option 1 is to kind of think about this in a log form. All right. If we were to change from an exponential to a log, how we just practiced, how if we would change exponentials to logs. So x equals, or x is the power of base 6 of 40. That gets me 40. X is the power of 6 that would give me 40. All right, so I turned this into a log. Why did I do that? Well, previously we tried to use common bases, but there's no power of 6 that's going to get me 40. 6 to the second power is going to be 36. That's as close as I get. And now we're going to be dealing with decimals, as you will soon find out. All right, so here we have it set up like this. And now we can use our change of base. Okay, x equals log, common log of the big number, 40, over common log of the little number. And now that little number is a big number, in this case, 6. And we type that in. Make sure you close your parentheses. .0588. Okay, another way to think about this that gets you the same answer. Okay, and I think it's a little bit easier to think about. You might agree, you might not. You might like this way. We just spent a couple days doing that. Okay, is I'm going to do or take the log of both sides. And this gets a little messy in other situations, so maybe you don't want to do that. Okay, and now I can bring that x down in front. And then we would divide by log of 6, and we still end up in the same situation. Okay, we still end up with x equals log 40 over log of 6. It still equals 2.0588. All right, this way it was a little bit longer, like math steps, but I think it's easier thought process or easier to think about than trying to twist this around into a log. I don't know. Up to you. Two different ways. Both end up in the same spot. Whatever you think will work the best for you. Go ahead and try them both out, maybe throughout these notes, and see what happens. Okay? All right, if I log both sides. All right, now it gets a little tricky here. You bring this whole thing down in front using our power property of logs. So we have x plus 2 times log of 2.1 decimals equals log of 8.25. Okay, we're going to divide. Divide by log of 2.1. X plus 2 equals, all right, we'll type that in. And I'm not going to write it, well, I'm going to write it down, but I'm also going to leave it on my calculator screen so we don't lose any decimals in our rounding. So we've got log of 8.25 divided by log of 2.1. Okay, and we get 2.8442. Okay, and now we have to subtract 2. Okay, and we have x equals, now I'm going to type it in again over here. I left it on my calculator screen, minus 2. All right, and I should be getting 0.8442. Okay, so we took the log of both sides. You could have just as easily done this. Took the log of both sides. All right, that allowed me to bring the exponents down in front. That was our big thing from section 7.5. Okay, so I have this whole parenthesis times log of 2.1. So I'm dividing by log of 2.1. Now I'm going to subtract the 2 over, and we're done. Okay, let's see here. Can you handle... Well, let's do number 3 together yet, and then maybe we'll turn you loose on 4. 5 is a different type of problem there. It's a little bit more complicated. Okay, and then we'll turn you loose on 6 to try it on your own. Okay, so same process for me at least. Log both sides. Log allows me to bring the exponent down in front. Okay, x squared times log of 7 equals log of 20.42. Okay, divide by log of 7. So if I divide by log of 7, let me use a red pen there so you see that. .5502. All right, so x squared equals 1.5502. Then we're going to square root. And we get about 1.2451. Okay, we should probably put a plus minus there. Negative answer was still giving you the same thing, and it wouldn't have affected anything to make any inaccuracies in there. Alright, let's have you hit pause here and try. Now this is not an exponent, like it's not an exponent in an exponent. It's not like x squared. This is 5 to the power of 4 times n. It's not the same as this. Okay, it's not an x squared. It's not n to the 4th up on top there. But go ahead and give it a shot. We'll see how you do. Alright, log both sides. Bring the exponent down. So you're going to get 4n times log 5 equals log 33. Okay, we're going to divide by log 5. So we got log 33 divided by log 5. We got 2.1725. And now we divide by 4. 0.5431. Neato. Alright, we're to the tough ones now. We are to the tough ones. Okay, there's x's on both sides. X's on both sides is going to make it a little more complicated just because you have more x's to keep track of. And you will probably have a few of these here in your homework. Okay. So what it's going to have is just basically an extra step involved. All right, we'll see what's going to happen here. So we're going to log both sides. Okay, bring our exponents down in front. That's an X right here, guys. That was going to be, I can't think of what letter I wrote down the first time. I was like, no, that's a mess. It's going to look funny. It's going to look like a different number. We're just going to use X. So we got X times log of 5. Okay. Now, it's tough. We're kind of stuck because we have X's on 2 different spots. So what I need to do is just like an Algebra 1 kind of problem, is get your X's on the same side. So in order to do that, you have to multiply this out. X times log 11 and negative, because it's a minus 3, negative 3 times log 11. Okay, these get kind of, they're not hard, it's basic stuff, right? Distributive property, combining like terms. It's just that there's so many steps. There's so many steps. Okay, so here it's all separated out. Now let's get our x's together. So I'm going to subtract that one over. So now I've got negative 3 times log of 11 equals x log 5 minus x log of 11. Okay, these both have an x, so I'm going to pull that x out in front. Okay, and then one big step, we're going to divide this all over, because there is subtraction in here. It's like, why are we dividing? It is subtraction in here, but it's x times this quantity. If you wanted to type this out and get that number and then divide by that number, you sure could. Okay, it's going to be a little bit messy because you're going to have to round, divide by your rounded number, and round again. A little bit chance of error there. I would suggest just typing it in with parentheses. Okay, so you're going to type it all in at once. Ready? -3 times log 11. Enter. That's our top row. Divided by parentheses log 5. Close that parenthesis. Minus log 11. Close that one. And then close the first one. So you should have a double at the end. Okay. And we're going to have 9.1237. All right, you want to test it out. It should be close. We did round it a little bit. It's just going to be close. It might not be exact. 11 to the power of 9.1237 minus 3, and then 5 to the 9.1237 power. Ta-da! Pretty close. Okay, you don't think those decimals matter when you round, but look at that, 2,383,000, and then we have a difference there in the hundreds already. Okay. All right, so you can do this one on your own. Push pause and try it on your own, and then I'll go through it a little bit faster here in 1 second. All right, here we go. Log both sides. Bring the exponents down in front. Okay, now we want to get x's on the same side, but in order to do that, we have to distribute this, because otherwise this x is stuck in this parenthesis. So I have x times log 7 minus 1 times log 7 equals x times log 4. All right, we're going to subtract this over. So I have -1 times log 7 equals x times log 4 minus, I subtracted it over, this was positive over here, so I have to subtract, minus x times log 7. Okay, these both have x's, let's factor it out in the front. Log 4 minus log 7. And again, if you want to, you could type that in, log 4 minus log 7, get that answer and divide by that answer. But then you're going to be rounding twice. Okay, you could be potentially rounding twice there. And you saw just with what one rounded number did over here, we are off in the hundreds position, which seems like a pretty big difference. Okay, when you're dealing with exponents, these numbers get really big really quick. And a rounded answer can have actually a pretty drastic impact. Okay, so I'm going to leave it alone. We've got -1 times log of 7 divided by that set of parentheses, log 4 minus log 7 equals x. Okay, carefully typing this in. -1 times log 7, close that parenthesis. I like to hit enter there. That's the top row. Okay. Divided by the bottom row, parentheses, log 4, close the parentheses around that 4, minus log of 7, close your parentheses around the 7, and another close parentheses to close the one we started with. 3.4772. All right, guys. So there should be a worksheet right here with the video where you found the video on PowerSchool. A worksheet involving 7.5 and 7.6. All right. Thanks for watching, guys.